Hello everybody, my name is Jennifer Pinney. I'm here to present part of my PhD project that was based on techniques to assess the bioavailability of copper and zinc in intertidal mudflats and the effects of those metals on the polychaete Nereis Virens. So hopefully I'm going to try and make myself understand. The main goal was to obtain a range of bioavailable concentrations of copper and zinc in the UK in order to use environmentally relevant concentrations in a future laboratory experiment and assess the impacts of those metals, of copper and zinc, on one specific species of ragworms and use a range of biomarkers. When I say bioavailable, I mean the part of the metal that's available to incorporate in the tissues of the animal and not the total metal concentrations. So we selected 7 sites that I've listed here based on 3 main criteria. The metal pollution history, that some of those sites were affected by heavy metals. The fact that they were dug or undug sites by bag collectors because the turnover of the sediment can affect the bioavailability of the metals in the sediment. And they all needed to be habitat of the ragworm Nereis Virens. So all those informations were obtained from different sources, the Environment Agency, personal communication with different laboratories, and also a great website called the National Biodiversity Networks Gateway, where if you need to know the distribution of one of the species in the UK, that's where you should go. So, on all of those sites we collected some sediment using this little core here that you can see, followed by a sequential extraction that I'm going to quickly show you on the next slide. We built a pour to extract a device, shown here, and that allows you to take some pour to samples in between the sediment, followed by nitric acid extraction, and then with a fork and a bucket collected some ragworms, followed also by nitric acid digestion. And all our samples went to a flame atomic absorption spectroscopy to assess the metal concentrations in our samples. So why we chose the sequential extraction, it's a 3-step procedure that allows you to see the bioavailable part of your metal. So I've listed here the 3 fractions of the metals. It has been successfully applied to marine, to lake sediments and contaminated grounds, and it supplies reference material, so then you can compare your data with this reference material. The main disadvantage is a very long process, and it uses various chemicals. For the pour to extract a device, it's quite simple. When I say simple, I was able to build it, so I think everybody can. And it's inexpensive. You can use PVC material and nylon mesh for the filtration. And it's based on a vacuum system with a syringe, so it has to be airtight. And it's well adapted for muddy sediment. The main inconvenience is that it can take you several attempts to actually create that vacuum because it needs to be airtight. So what we have so far is site characteristics with the sediment grain size, the organic content, the temperature, salinity, conductivity, dissolved oxygen, the metal concentrations in the sediment, the water and the animals, and how it's all linked together. And why we did all this was to have, we wanted to have a range of bioavailable metal concentration for a 9-month experiment that I was going to run in the lab. So moving on to this 9-month experiment, we used a range of biomarkers to assess the impacts of metal concentration on this species. So every week we looked at the feeding behavior. We also looked at metabolic profile through the protein, lipid, carbohydrate levels, lysosomal stability. I'm not going to go into too much detail, but it's just a list of different biomarkers that we've done. And the CaBA assay, as Lorna showed you in the previous presentation. And I guess here is trying to figure out how we all link together and how we can incorporate our biomarkers and our data with you guys. So, thank you.
Yeah.